Hi, welcome to lesson 2C, Domain and Range. The goal for today's lesson is to discover what the domain and range are and how they are applied. So from section A, we will recall that the domain was the set of possible values on the variable in the horizontal axis, and therefore can be thought of as a set of x values in the relation. And the range is the set of possible values in the variable in the vertical axis, and therefore can be thought of as the set of y values in the relation. The domain and range of a relation are often described using set notation. Now, some of the notation that we have here, we've got different number sets. And one set of numbers is represented by an n, a capital kind of N with two lines through the middle here. That's a set of positive integers and 0, the natural number system. And so they're basically the counting numbers including 0, and they just go up from there. So the positive integers and 0. Z is represented by the set of positive integers. The set of all integers. 0, plus or minus 1, positive or negative 2, positive or negative 3, etc. Z positive is the set of positive integers starting at 1 and going on upwards. There of course would also be a set of negative integers, would be represented by a Z with a negative in the superscript there, and they would be negative 1, negative 2, negative 3, etc. R is the set of all real numbers, and that means that they're all the integers, all the decimals, all the fractions, everything that is considered quote quote a real number. And our superscript plus would be the set of all positive real numbers, whereas the set of all x values such that x is greater than 0 and x is an element of all real numbers. There could also be a set of R negative, the set of negative real numbers, which would have x, or would contain the set of all x values such that x is less than 0, but x is still a member of all the real number system. Okay, number line graphs. There's a way for us to determine or depict on number lines what values are represented in a set. So if we have a set of values, in this case, x such that the set of all x values such that x is greater than or equal to 2, we would draw this on the number line by locating 2, and it would be right about there. And because we know that it's less than or greater than or equal to, it includes the 2, so that means that we're going to put a solid dot on 2. And then from there, we're going to draw, because it's greater than 2 now, it's including it, so that's why the dot is there. And greater than 2, we're going to now draw a line. Sometimes you can draw a line above the number line that's given. I sometimes will put a double line to make sure that we can see the line for the number line below. Okay, so that's how you would graph on a number line the set of x values that are greater than or equal to 2. For the set of x values such that x is less than 4, well, we want to locate 4, and now it's really difficult to draw accurately enough a number that's close enough to 4 but not including 4. So in decimals you could say, well, there's 3.9, or you can go to 3.99 or 3.999, or you can get really ridiculous and say 3.99999. But no matter how many 9s you place there, you can never draw it close enough to the 4 to really accurately depict that. You'd have to magnify your view 1,000 times and it's still not close enough. So what we do is, instead of having a closed circle saying that it's containing the value like we did up here with 2, we're going to have an open circle to show that it's as close as possible to 4, but just not including 4. And then, because this is less than 4, then we'll draw the line to the left. So it's going from 4 and down to the left towards the negative values. And then that will we just have an arrowhead here to show that that goes on forever, because it's all values less than 4, and just goes on forever to the left. And now if we look at something a little bit more complicated, we've got a set of x values such that x is less than or equal to 0, or x is greater than 3. So in math, or basically means the same as what we would say in real life saying and, like kind of both things. In math, if we said and, that would have to be like an overlap. They'd have to contain the same values. But for or, it's this or this, meaning it's kind of both. So for x being less than or equal to 0, well, because there's the equal to sign under the less than, we know that there's a closed circle because it's containing 0. It's a closed circle. Here for x greater than 3, well, because there's not an equal to part of it, it's going to be an open circle on 3. And then for the x we know is less than or equal to, so then it's all the values to the left or smaller than 0. So we'll just draw the arrow here to the left. And for the 3, x is greater than 3, so it's all the values to the right, and therefore greater than 3. Okay, moving right along now. Now we want to take a look at these examples, and we want to determine the domain and range for each of these relations. So remember that the domain is the set of all possible values on the horizontal axis. So if we were to take a look at all these points, all the many, many, many millions and millions, infinite number of points that make up this parabola, we would see that because it goes on forever in both directions, it goes down steeper than it goes to the side, but eventually it would go to the side in either direction, to the left and to the right, to positive and negative x values forever and ever and ever. So that will cover every single possible x value that exists. So the domain is the set of all x values such that x is an element of all real numbers. So they'll include whole numbers, they include integers, they include decimals and fractions, all the rational numbers, so they include every single real number. When we look at the range now, the range is the y values such that, and we see that all the y values are included starting at positive 1. And see there's a closed circle there, meaning that 1 is included, so it's all the values that are less than 1 and including 1. So the set of all y values such that y is less than or equal to 1, and y is an element of all real numbers.